Hey everyone! You've got me in the middle of chore day. Since you're here, maybe you can help me out? At least with the math part. We've been learning about the Pythagorean theorem lately. I wonder if it could come in handy here. First up, the gutters. Not a glamorous job, but it's got to be done. Now, I have a 12-foot ladder, and I need to get up to the gutters that are 11 feet off the ground. How far away from the house will the base of the ladder be? Let's see how it all shakes out. First of all, it would be really helpful if I could visualize all of this information. Let's make a sketch. The house meets the ground at a 90-degree angle. The gutters are 11 feet off the ground, and I'll want the top of the 12-foot ladder to reach the gutters. What I'm looking for is this distance, the distance from the house to the base of the ladder. This is making a familiar shape, a right triangle. Just like any other problem we've done involving a right triangle, we should first identify whether the missing side is a leg or the hypotenuse. What do you think? Yes, the missing side is a leg. And which side is the hypotenuse? The one across from the right angle, which is the ladder. Great, now that we have that figured out, take a moment to pause and determine the distance from the house to the base of the ladder using the Pythagorean theorem. First, we have the Pythagorean theorem itself. A squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse. Since 11 is the length of a leg and 12 is the length of the hypotenuse, I can write the equation 11 squared plus b squared equals 12 squared. You may have used a different variable, and that's fine too. Squaring both the 11 and 12, and then subtracting 121 on both sides gives me the equation b squared equals 23. Now we can take the square root of both sides, so b equals the square root of 23. While the square root of 23 feet is the distance from the house to the base of the ladder, it's not in particularly useful format. My measuring tape doesn't have square roots on it. My flower bed is 5 feet from the house, so will the ladder run into my flower bed or not? I think we should estimate the value of this square root. To estimate the square root of 23, I need to locate the two perfect squares on either side of 23. In this case, that's 16 and 25. Since the square root of 16 is 4, and the square root of 25 is 5, I know that the square root of 23 is some number between 4 and 5. So, can I reach my gutters without running into my flowers? Yes! We found that the base of the ladder will be between 4 and 5 feet away from the house, and my flower bed is 5 feet away from the house. It'll be a little tight, but my flowers will survive. Perfect. I'm going to clean out those gutters while you help me check off the next item on my list, picking a slide for the backyard. Here's what we have. The top of the slide needs to be 6 feet above the ground, but the bottom of the slide must be 8 feet away from the bottom of the playset. So, how long does the slide need to be? The store has 3 options for slide lengths, and I'm hoping one is the right fit. Pause now and determine what the length of the slide should be. It may be useful to start with a sketch. Let's see how we're doing with the slide. Another sketch would be useful. We can draw a right triangle like this, where one leg represents the distance to the top of the slide. One leg represents the distance to the bottom of the slide, and the hypotenuse represents the slide itself. We know that we are missing the hypotenuse of this triangle, so we can set up the equation 6 squared plus 8 squared equals c squared. Then we can simplify the left side of the equation, which gives us 100 equals c squared. We can now take the square root of both sides, and we see that c equals the square root of 100. Can we simplify this square root? We can! The square root of 100 is exactly 10. No need for estimating. Looks like the store does have the right size slide for my backyard. All right, checking things off the list. Thank you so much for your help. I've got the gutters cleaned, and now I can go pick up the 10-foot slide from the store. I've got one more thing on my list. Maybe you can take a look while I grab the slide? Here's what we have. I found a great deal on a used laptop, but I need to make sure it's the right size. You see, computers, computer monitors, and TVs are all measured by the length of their diagonal, but the person selling this laptop only listed the length and width. The advertisement says that it is 8 inches by 11 inches, so what is the size of the laptop? I'm looking for at least a 15-inch laptop, so I'd like to know whether this one fits the bill. A quick sketch of this situation might be helpful. How about you try sketching this scenario yourself? I'll sketch a rectangle to represent the laptop and label the length and width as 8 and 11 inches. If I sketch the diagonal of this rectangle, I see a familiar shape, a right triangle. The diagonal of the rectangle is actually the hypotenuse of this right triangle. Pause now to set up and solve an equation to find the length of the hypotenuse. We're missing the hypotenuse of this triangle, so I can write the equation 8 squared plus 11 squared equals c squared. Simplifying the left side gives me 64 plus 121, which is 185. Then we can take the square root of both sides, leaving us with c equals the square root of 185. Just like with the ladder, this is the length we're looking for, just not in the format we want. We need to know whether the hypotenuse, the diagonal of this laptop, is greater than 15 inches. So, is the square root of 185 greater than 15? Let's estimate the square root of 185. Well, 185 is between 169 and 196, so the square root of 185 is between 13 and 14, which is less than 15. Looks like this laptop isn't going to work out. I'll have to keep looking. Whew! I've cleaned the gutters, picked up the slide from the store, and taken the computer out of my online shopping cart, all with a little help from the Pythagorean Theorem and you, of course. Today, we explored how the Pythagorean Theorem helps solve real-world problems by calculating distances and estimating square roots. Make sure you finish up these notes before you attempt the online practice. And remember, math is everywhere. Keep exploring.
Hey, hey.